We're going to begin talking about data visualization. And in this video, I'm going to cover some kind of fundamental aspects of how and why we use data visualization, and then talk about the process of moving from a data set to a useful visualization. Before I do that, I want to really quickly review some basics from our discussions of data. And specifically, I want to talk about data types. So we've covered this before, but really quickly, different columns in our data are going to have contain different types of data. So if we have a spreadsheet or a data set like this, we're going to have columns such as E that contain what I would consider textual data. Okay, so it's text, but it's not categorical data. So least type, I'm going to say, is categorical. It's one of a set of options. And then we also have numerical data. Number of units is numerical. It might go from 0 up however far it needs to. And we might also have date data that represents a point in time. And we'll come back to these and talk about how our different data types correspond to different types of graphs that we can create. But first, let's talk about why we use visualization as a way to understand large data sets. So if I give you something like this, and I give you a task, and I say, how many 5s are in this data set? You're going to have a very hard time, right? There's a lot of cognitive load involved in this. It's not intuitive for us as humans. But if I now say how many 5s are in this, it's much easier for us, right? Human eyesight evolved in certain ways. We are very good at some visual tasks. Our eyes take in an just enormous amount of information about the world all the time, and our brains are very good at processing it, grouping it, categorizing it, finding differences in some very specific ways, and we are not good at finding differences in certain ways. So what we're doing with data visualization is we're harnessing all of that kind of like amazing and very intuitive computing power that we have in our brains, and we're formatting our data in such a way that we can employ that, right? Because if I look at a spreadsheet like this, I can't understand this column of numbers very well, but if I look at it visually, then I'm much better able to do this. This is a kind of an interesting example of just how good our brains are at doing these things. So if I said, what's the odd one out here? Obviously, for me at least, it's this red one at the bottom. If I said, okay, group these, how would you group these? Obviously, I'm going to kind of take these yellow ones at the top, these orange ones, and I might say this red one is kind of a strange one or an outlier. And what this visualization technique does, it's called Chernoff bases, is it maps different aspects of a data set to different physical features of a face, right? So things like nose size, nose color, skin color, hair shape are mapped to different, literally different columns in a data set. Where if I looked at the data set, I couldn't group these rows together. But if I turn them into visual features, and especially visual features that are similar to something that our brains are so attuned to, such as faces, then all of a sudden all that cognitive power lets me really quickly sort through something that I couldn't otherwise. So turning to how we use visualization, there's really two main uses. A lot of times I have a data set and I am trying to figure out what to do with it. I might be a scientist and I'm just kind of I'm looking for maybe what it tells me. I may be a journalist, in which case I'm trying to find stories in the data. I'm looking for patterns that I might then pursue and do further work on, right? And the other way that we use visualization a lot of times is to communicate meaning or takeaways from data to an audience, in which case I'm using the visual form as a way to let readers understand something that they couldn't otherwise. I can't expect a reader to look at a spreadsheet, but if I show them a graph that indicates what I want them to get out of it, then that's much more effective, and it's a way to give readers access to these much more complex situations than they might not have otherwise. And in this video, we're going to mainly focus on the analysis part, the analysis exploration part. So here are examples of visualizations used primarily for analysis. Here's a visualization that a scientist might use to understand the relationship between study time and the grade, right? So here I can quickly understand that as I study more, I get better grades for the most part. Here's a kind of more complicated visualization that scientists use quite often. This isn't something I would publish in a magazine probably, but for a scientist, this gives me a lot of visual information to sort through and think about and decide what I want to do next. On the other hand, in publications, magazines, websites, we often see data visualizations like this that are very much meant to be looked at for a reader and have some additional features like captions and things like this. So data visualizations can also be used to tell stories in this way, or can form a really integral part of an argument. Okay, so if we are going to talk about data visualizations, we need to really fundamentally understand what can we do with the visual medium, right? And so we need to talk about some really fundamental things like color, size, right? If I'm working with a two-dimensional space, what can I change that can then be meaningful? And then how can I express these different features in relationship to my data, and more specifically to my different types of data. So I'll run through this as I move through. So color, right? I can change the color of something, and I can change that in order to express categorical data. So if I have a column in my data set that shows me which presidential candidate that row corresponds to, I can then color the marks that I am putting on paper to indicate that, and that lets me track different categories, right? In this scatter plot, I can show the different countries and which continent they're on. This is a categorical variable, and then my brain can use the color here to really quickly see patterns. I've got a lot of green here. I've got a lot of orange here. That can be a very powerful way to sift through a lot of data points. I can also map color to a numerical value. Okay, so if I just have a column that shows the amount of precipitation in inches, okay, that's a category, or that's a numerical column in my data, and I can then map that to a scale so that like a light green is low and dark blue is a higher number. Same thing here. When I'm using color, I want to be really careful. And I want to understand how our eyes and our brains process color. So if you take a situation like this one, or this one, where I can really easily sort through and find patterns in the color, if I have too many colors, I lose that ability. So here, color doesn't add any meaning at all to this visualization. And in fact, it really just kind of distracts me. So you always want to be careful in thinking about how are you helping people to get meaning from your visualization, or how are you helping yourself get meaning from a visualization. If we talk about size, one of the ways we can talk about size is length. So bar charts are an example of using length and mapping it to a meaning. So here to a numerical category, or to a numerical column in our data. And our eyes are really good at comparing length and even kind of understanding the difference between lengths, right? Like purple looks 3 times longer than red to me. So I'm understanding kind of minute differences with length. The other way that we can use size is area. But area is much harder for my brain to grasp, especially if I'm trying to understand differences, right? So like, how much bigger is this orange from this blue? That's much harder for my brain to understand. And a good way of thinking about this is a pie chart and a bar chart, right? This represents the exact same data. The bar chart is only using length to represent it, and the pie chart uses area. And again, it's easier for me to understand the relationships in a bar chart than in a pie chart, just because area, especially on a circle, is much harder for my brain to grasp. This is just an example of bringing together color and area in a way that kind of does work. I can understand here which countries are larger, and because I combine it with color, I get a lot of information that if I really want to dig into this map or this visualization, I can. Position, right? This is a very fundamental visual feature. When we're making visualizations, we're putting marks on paper, basically. And so where those marks occur can tell us a lot. Here I'm seeing where shots were taken. So position is really the best way that I could show that in relationship to a basketball court. I can map position to a numeric value. This is largely how we do it a lot of the time. So I can have X and Y axes, and the position along those axes would map to a different column, numeric column in my data. I can also associate position with a categorical value in my data. So here my data set is going to have red, orange, yellow, purple categories, and then I separate those based on position. This is an example of a time when position is completely wasted. Where these marks are means absolutely nothing. So this could have been a bar chart, it could have been any other kind of visualization. But here, color and position really don't tell me anything, and they hurt my ability to gain meaning from this. So this is an example of something to avoid. So shape is another fundamental visual property, but it's also one that our eyes have trouble with, especially when it's used here. So I have a lot of trouble telling circles from squares here. The patterns that I would be getting from this would be much more obvious to me if it used color instead of shape, for example. So there's very few times when using shape like this really aids in your understanding. So now I want to start talking about how different data types and different columns that we might have in our data can be turned into different standard graph types. And this is really important because when we're creating a visualization, what we're doing is we're trying to gain a deeper understanding of some column in our data, or the relationship between multiple columns in our data. So you can very literally say, okay, I want to understand this type or this column of data. It is this type. What graphs can I make from that? And I'm just going to run through these. So if I have a numeric column and I just want to understand that column, I can use what's called a box plot. Okay. And box plots helped me to understand not only, say, what the median value for that column is, but how everything is distributed around that median value. I'm not going to go through everything about how to interpret box plots. You can read a little bit more, but you need to know this line in the middle is the median. In these boxes are where a lot of your values are clustered. You have a maximum and a minimum, and occasionally you'll have dots that show points that are significantly outside what is normal. Okay, so miles per gallon here, highway miles per gallon for different kinds of vehicles. If I look at subcompact, I can see where the median is. I can see where a lot of my values are located. And I can see that there's a couple examples that are kind of way off, right? And if I could compare that to something like a minivan, I can see that these values are much more tightly clustered. There's a lot less variance here, and there's one outlier down here. So I can get a lot more information from this than I can from just a median or a mean. Another way of understanding just one numeric column is a histogram. And so what histograms do is take your value and separate it into what are called bins, so ranges. If we take, say, this bin right here, this looks like it's maybe, 280 to 290, the value. And then your y-axis is going to show you how many of your rows of data fall into that bin. So I can see that, okay, most Airbnb apartments kind of are in this area, and they taper down. I've got these weird bumps. So that gives me a lot that I can start digging into. And again, it tells me a lot more than a median or a mean does. If I want to understand the difference between, or not the difference, but the relationship between two numeric columns, I'm going to use a scatter plot. Okay, so a scatter plot puts one of your columns on the x-axis, one of your columns on the y-axis, and then puts a dot for each of your rows so that I can see patterns largely, right? And the way that I would read this is as study time increases, goes this way, mark or grade largely increases, right? So I can see a trend here of a line kind of going diagonally up and to the right. Scatter plots are also really good for finding outliers, right? This is a strange person who studied a lot and didn't make as good of a grade as we would have expected. Scatter plots are also a great time where we can add and layer information on top of it. I can add color to this if I have a categorical variable. I can add size to this if I have another numeric variable. So you can kind of combine these things and really start building deep opportunities to understand your data. If I have a categorical variable and I want to understand its relationship to a numeric variable, I can create a bar chart, right? So categories across the bottom, numbers on the top, or along the y-axis, along the side. If I have a date column and a numeric column, I can create a line chart, okay? And here the line, we use line charts to basically suggest that there's a progression here, right? That this change occurred over time. So largely we use line charts when we're dealing with a date column. The last one I'm going to touch on is if I have two categorical columns that I want to understand the relationship between. I call these heat maps. You'll see different terms used here. But the big idea is that I'm going to have one of my categories along one axis, one of my categories along the other axis, and then where these intersect, I'm going to somehow visually indicate how much intersection there is there. So if a lot of chairs are sold in September, I want to visually see that. So this is just a way to visually look for patterns and look for convergences. So there's a lot of other graph types. Those are the most common. And again, really what you're thinking about is as you're building the graph, how am I using visual features, things like color, shape, size, position, to let my eyes do that computational work, look for patterns, look for outliers. And then as you start to go from a data set to data visualizations, what columns do I want to understand? What graph types can I then create from those columns?